Now we're going to talk about hyperbolas. So that's a different conic section than an ellipse. And hyperbolas go either this way, they kind of branch out. And we can center them at the origin, or they can be centered elsewhere, or they can go up and down. So they're not really parabolas. They might look like parabolas, but they go toward what are called asymptotes. So in here, there's like a little box, and we'll show you how to graph these, but it kind of helps to see that box. And you have these asymptotes that go through the corners of the box. And then, well, now I should have drawn that first. Anyway, the hyperbola goes toward those asymptotes. So my one looks like it's crossing it, and it shouldn't do that. But same thing here. You have a point here and a point here. Those are called the vertices. And then that makes... There's a little box in here that we'll show you how to make. And then those diagonals are the asymptotes, okay? So hopefully that helps a little bit. Maybe not. This point right here, that's going to be the center, okay? So the center could be at the origin, or it could be at HK. It could be at the origin, or it could be at HK. In fact, let's not talk about the origin. We can surmise what that's going to be, but let's just give you the example for the one centered at HK. Okay. So the standard form for these, like if it's opening to the sides, that one's going to be x squared over a squared minus y squared over b squared equals 1. And then if the hyperbola is opening up and down, the y squared is first. Y squared over a squared minus x squared over b squared equals 1. Notice that the A stays with the first term and the B is with the second term. Let's see, what else do we want to know about that? It's subtraction. So one of the ways you're going to know it's a hyperbola is there's going to be a subtraction sign between the x squared and the y squared. With the ellipse, it's addition. Okay. So the vertices, so I'll change my ink here. The vertices are right here. It's where the hyperbola is touching that box, and it is in line with the center, okay? And then these, I think we already do the vertices there in blue. The co-vertices, it's part of that box. So the co-vertices are going to be up here and down here, and over here and over here. You need those to make the box. So it's almost like you're drawing an ellipse, except you draw a box instead with the A and the B, just like you do for an ellipse. But instead of drawing an elliptical shape, you draw this box. You need the box so that you can draw the asymptotes, okay? So those asymptotes were in blue. Okay, the foci, let's see, I'm using up all my colors. The foci are inside. So like the foci is in here, and then up here and down here. They're inside the hyperbola. The hyperbola wraps around the foci. Okay. The transverse axis, let's see. What color shall I do that in? The transverse axis is the distance between the two vertices, okay, and it goes through the center. So that's the transverse axis there, and then that's the transverse axis there. And then the other one is going to be the conjugate axis, and it's going to go through these, and it's going to go through those. Okay. I think we got everything in there. Now we'll go to an example. I wasn't going to spend quite as much time with a hyperbola. Most of the work that we do with the ellipse is, you know, you can kind of say, well, that's going to be the same thing only with a hyperbola type thing. But I did want to do an example where we're going to get it in standard form and then we're going to go ahead and graph it. So again, we're going to get the x terms together. It's in general form right now. This is another example of one of these. And then you've got your y terms. And then that 338. And go to the other side, that's the constant. So remember I said sometimes the numbers are big, don't let that scare you. Okay. So let's factor out a 9. I know what we're used to doing. Leave a little space, we know we're going to complete the square. Now here we're going to have to factor out a -4. So we need that y squared to be positive. So it's going to change the sign in the parentheses there. Okay. And now let's go ahead and complete the square. So half of -4 is 2, -2 squared is 4. So we're going to add 4 here. But really that's a 36, so add the 36. And then half of 10 squared, or 5 squared is 25. You'll see a lot of the same numbers pop up. Now that's going to be a -100. Okay. Don't want to run into my graph paper. Okay, so now let's go ahead and start getting it into the form. 9 times x minus 2 squared minus 4 times y plus 5 squared. And all of this over here is going to equal what? So you've got 288 plus 36. Maybe I should add the 36. 424, 324. I want to say it's 324. Let me check that. Okay, so yeah, that looks good. Let's go ahead and divide by the 324. So it is positive. Now hopefully 9 goes into 324. I think it does 36 times. Let me double check. Using my calculator. So that's nice. 36 is a perfect square, so that's, I don't know why Netflix is there. Okay, forget about Netflix. All right, then how many times does 4 go into 324? I think it's going to be 81. This is going to be a giant hyperbola. Okay, but it's in standard form. Okay, so the numbers do work out nice. They're a little large, but they do work out. Okay, let's go ahead and start graphing this then. I think I'll do this part in green. So here's what we're going to do. We're going to go to the center. The center is going to be at 2, -5. I don't know, I might not be able to fit it on my little graph paper here. 2, -5. Down there pretty far. We'll just have to see. So, yeah. Yeah, it's going to go off, but that's okay. So A is right here. That's a squared, right? Okay, so A is 6. So if I count from the center along the x-axis, now notice the 36 is under the part that has the x squared. So I'm going to go in the x direction, 6 units. 1, 2, 3, 4, 5, 6. Way out here. 1, 2, and over there. And then my b squared is going to be right here. So b is 9. So going up 9, that's fine. But it's the going down 9. So 1, let's see if I can get it to mark. 1, 2, 3, 4. So maybe right there. All right, so here comes the box. We go through the vertices along these lines that we have because of our nice graph paper that was too small in this case. Okay, so, and then here come the asymptotes. The asymptotes, and I see students kind of rush through this sometimes, the asymptotes are going to go through the corners and the center. So in this case, I'm going through here, and there are equations for these asymptotes as well. You could think about the slope and you could get those fairly easily, or there's formulas in the book. I'm not spending as much time on the hyperbola though. Okay, now we have this box, we have the asymptotes. We have to know though, is it going along the x-axis, is it going sideways or is it going up and down? And in this case, because the x squared is positive, it's going to be going this way. So what I'm going to do is I'm going to find those vertices that I kind of have covered up with my box, but there's the vertices, and then I just try to draw it toward the asymptote. This is kind of a wide one going here. These don't always look beautiful. In the book they look beautiful. But, okay, and then that's the graph. So we get it in standard form, and then we find the center and the A and the B, count everything out, draw the asymptotes, find the vertices, and draw the hyperbola.